So we go to section 6.2 today. So the first part of trigonometry equation. Trigonometry equation is pretty much just a conditional equation. Conditional meaning that it only works for some certain values of the angle, and it will contain a variable. So pretty much an equation that has trigonometric expression in it. We'll just jump right to the first example. Find one solution. So we'll find all the solution, and we want the answer in degrees and gradient. Right. So first, when we look at this problem, we can use a calculator to get the answer. But the first thing we learned from last time was, if sin x equal to square root of 2, one way to get one answer is just take the inverse. So I just write, this is not the actual solution though. So if we want to get back to x, we'll have the inverse. And the sine side inverse cancel out only on some certain condition. So in that case, you get at x equal to sine inverse. that certainly works for only one solution. I emphasize that this only works for some certain values of x. So this is one way to do it. Now another way is we look at the unit circle. So here we have a unit circle. The sine is the y values. So we look at the y values. That equals square root of 2 over 2. So square root of 2 over 2 is here. The y values, that and that, right? So this red dot here and the red dot there. So correspondingly we will pi over 4, 45 degrees, or 3 pi over 4, 135 degrees. So on the unit circle, that's what we have. So we have x equal to pi over 4 or let's do both, 45 degrees. Or we can also have x equal to, so either this point here or this point here, or x equal to 3 pi over 4, because those 2 points have the same y values of square root of 2 over 2 and sine is the y values. So either that or 135 degrees. Right. So that's easy, right? But what happens if we don't have the 9 values like square root of 2 over 2? We could have like 0.4 or something like that. We need a more general formula. Certainly we go to the general formula, but before that, let's note that when we have the answer, if we want all the solution, when we have one point, just this one, 45 degrees is corresponding to the point here. And 135 degree correspond to the point here. And so that's certainly the solution. However, we can go extra revolution or many times over. So instead of writing the answer like this, we can say it pi over 4, and we can have extra revolutions. So we should say coterminal angles. So in that case, there will be 2k to n pi, or n times 2 pi, and then all, if we use degree, 45 degrees plus n times 360 degree. 360 degree is extra revolution. So we have the coterminal angles. So that is solution corresponding to that point. Now we write similarly, we write the solution corresponding to that point. 3 pi over 4 plus 2n pi, or 135 degrees plus n times 360 degree. Right, so that is the first problem. Notice that the sine will have the solution across from the y-axis. Right, next. Cosine of theta negative square root of 3 over 2. Right, so this is also special values. So again, we will look in the unit circle. Cosine will be the x values, will be the first part of it. So that is where negative square 3 over 2 are the x values of the point, and corresponding to 6 pi, 5 pi over 6 and or 150 degrees. So we have x equal to 5 pi over 6. Sorry. Uh, 5 pi over 6 is corresponding to 150 degrees. And then the same x values, if we look at this point here, also the x values is negative, so we have 3 over 2, and we have 7 pi over 6 or 210 degrees. So let's just plot 2 points. One solution is in the second quadrant, and one solution in the third quadrant. But then again, we might add a multiple of 2 pi to get coterminal angle. We can go extra revolution around it. As long as we have this point, we're good. So we might have 5 pi over 6 plus 2n pi, or 150 degrees plus 2n n times 360 degrees. 360 degree is 1 revolution, and we might have multiple of it. And same thing here, we might have 7 pi over 6 plus 2n pi, or 210 plus n times 360 degree. Next, we have tangent. Number 3, tangent of x equals square root of 3. Now, tangent are slightly more difficult. Tangent is y over x, or sine over cosine, and square root of 3. Tangent is, if we take y over x, square root of 3 over 2 divided by 1/2, this will be square root of 3. So we're going to have this point here. This point there, which is pi over 3, or 60 degrees. Right, so that is one point. Right, now if we go across from the origin, we go to another point here. I'm talking about this point, this point here, or this point here. If we take y divided by x, negative square root of 3 over 2 divided by negative 1/2 is also square root of 3. Or if we have that, or four pi over 3, or 240 degrees. Now, the difference here is, let me just draw it out. We might have a point here, or we might have a point here. The difference is those points across from the origin. So we actually can combine these two together as we say x equal to pi over 3 plus n pi, or we just combine these two together, x equal to 60 degrees plus n times 180 degrees. Right, 2 points to note here. For sine, cosine, we have n to n pi, or we can say n times 2 pi. Either way is the same thing, right? So the key here is 2 pi, and for tangent it's just n pi. So there are a lot of things that we can get out from this example, but I will write the note here. Note, for sine, cosine, the period is equal to 2 pi. So that's why in the solution it has n times 2 pi or 2n pi multiplied to it. And for tangent, the period is just pi, so that's why we just have n pi. So here we have n pi. So this is nice and all, but we cannot always refer to the unit circle, because on the unit circle we only have a few special points. What happens if the point is somewhere in between here, or some point in between here? We won't be able to tell it from the unit circle. So there must be a way in more general than this. So this is the first note. The second one, in general, for sine, you see the solution is on the opposite of the y-axis, right? Symmetric on the y-axis. So for sine, the solution is across the y-axis. For cosine theta, for cosine, the answer across from the x-axis. And then for tangent, the answer is across the origin. So across the y-axis, across the x-axis, across the origin. Even better, we have the device, this, which is the summary. Right, so let's write that down for all the formulas for trigonometry equations. C. And this is important. I use red. So if we have sine of u equal to a, then like I said, we cannot always go back to the unit circle. We cannot do that. So more general to that is something like this. If you have sine, taking the inverse, it will cancel, but for some very special values for x. So in this case, the solution, we will say u equal to sine inverse of a plus 2n pi. So that gives us one solution here. And now we need the other solution across from the y-axis. So either that is the one solution, or we have pi minus sine inverse of A plus 2n pi. So the pi minus sine inverse give us the point across from the y-axis. Right. So if that is in the radian in terms of degrees, we will have u equal to sine inverse of A plus n times 360 degree, or u equal to 180 degrees minus sine inverse plus 2n pi, which is n times 360 degree. And it will be better if we have the solution in terms of a graph. So let's try to draw this. Okay, good. So which means we have two solutions, one of which is here, which is sine inverse of A, and the other one will be across from the y-axis. Which is pi minus sine inverse of A. So we're going to have two solutions that is across from the y-axis. So that is the sine inverse for the sine equation 2. Now if we have cosine, if we have the equation of cosine, then the first part we will have u equal to cosine inverse, again plus 2n pi. So from cosine, go back cosine inverse, get us the angle, coterminal angle, or we have another values for that. And here I will write negative cosine inverse of A plus 2n pi. So in terms of degrees, u equal to cosine inverse plus n times 360 degree, or u equal to negative cosine inverse plus n times 360 degree. Right, so that's good. So let me just write draw part of the unit circle. Right. For cosine, we have two solutions. One of them is here. Cosine inverse, or the point that is across from the x-axis. And this is negative cosine inverse of A. So sine solution across the y-axis, cosine solution across the x-axis, and then on the coterminal angles, so 360 degree or 2 pi added to it. Number 3. Now we have tangent. If we have that, then we will have u equal to tangent inverse of A. Right. For tangent, the period is just a pi, so instead of plus n times 360 degree or 2n pi, this is just n times pi. There's not 2n. Or if we have in degrees, tangent inverse plus n times 180 degrees. And then let's draw the solution on the unit circle. Cosine is positive in the fourth quadrant. So I'm not talking about the cosine values is negative. Like if we're talking about, for example, 45 degrees here, and the other one is negative 45 degrees. We're talking about the angles values. We're not talking about the cosine values. Of course, cosine of 45 degrees is the same as cosine of negative 45 degrees. But in terms of the values of the angles, one is positive and one is negative. And one more thing about cosine. Cosine is an even function. So cosine of positive x is equal to cosine of negative x. Because cosine is even, cosine of x equal to cosine of negative x. Or cosine 45 equal to negative 45. Cosine 45 degrees equal to cosine of negative 45 degrees. So that throw in the negative here, because that gives us, this is an angle and this is negative of that angle. Yeah. So the values of cosine is positive, but the angle is negative in the quadrant 4. Yeah. So we go clockwise, so it's negative. Right. And there will be a few things we go with that too, but first let me draw a circle for tangent. Yes. So this direction is clockwise, counterclockwise direction, so this one is positive. And this counterclockwise is negative. So the angle is positive and the angle is negative, but the values will be the same. The trig values will be the same. Cosine of that and this will have the same positive values. Right. So cosine is opposite from the x-axis and tangent is opposite from the origin. So if we have a point here, a tangent inverse, then we have a point that is across from the origin. And to get the point from there to there, we're going to add a pi to it. Right? Now, so once again, for sine, opposite from the y-axis, cosine, opposite from the x-axis, and tangent, opposite from the tangent, opposite from the origin. Right, now put all of those together, I have this little device here. So we have sine, cosine, and tangent. So let's look at what we have here. For sine, of course, sine, cosine, tangent, they always have the inverse, sine inverse, cosine inverse, tangent inverse. So there's nothing different on those two. What different is, what is the other solution? For the other solution, we have pi minus or 180 minus. That is called supplement. So sine is supplement. For cosine, we have negative sign here, and that is opposite to that. And then for tangent, we don't have anything here, just one sine. So for sine, it is supplementary. Cosine is opposite. And for tangent, there's nothing here, right? So there's nothing different. But the end here is, notice that the period for tangent is equal to pi. Alright, so that's the summary of trigonometry equation. By the way, remember I did say that at the end of the semester I will ask you some part of the note. It will have this part in it as well. Right, now let's go to the first example. So yeah, just skip that for a moment. Pi. Let's go to example. Find own solution. So now we find all solutions, but only between 0 and 2 pi. And the equation is 2 sine of x minus pi over 4 plus 1 equal to 2. Right. So in this problem, we want the solution between 0 and 2 pi only. Right. So, in order to use trigonometric equation in this formula, we just need to have a sine, a cosine, or tangent. In other words, trying to isolate and solve for the trig function. So the first thing we do is subtract 1 on both sides. Just trying to get the trig function by itself. And then we divide by 2. So we have sine of x minus pi over 4 equal to 1/2. Now we have a trig function equal to something. Actually, take the whole thing. Divide by 2. Alright, now it says sine of something equal to a is either sine inverse or the supplement to it. So we will say in sine of the sine will be x minus pi over 4 will be equal to inverse, sine inverse of 1/2. And then plus n times 2 pi. We're going to use that or 2n pi either way. N times 2 pi or 2 times n times pi either way. This one we use this instead of 360 degree because we have the pi over 4 here. Right, so that is one solution. The other solution is be the supplement to it. The supplement meaning subtract from pi. Right. So we have x minus a pi over 4 equal to sine inverse of 1/2. Sine inverse of 1/2. Of course, that gives us in radian. But if we want a nicer answer, let's keep that in degree. It's 30 degrees. And we're not going to use degree here because the answer is supposed to give in radian. So 30 degrees is equivalent to pi over 6. And that is pi over 6 plus n times 2 pi. Right. And to get x by itself, which is plus pi over 4 so what is 1 over 6 plus 1 over 4 Right, 5 over 12. And then over here, do the same thing. And that gives us what is 1 minus 1 over 6 plus 1 over 4 and we have 13 pi over 12. Then plus n times 2 pi. Right. And finally, the solution between 0 and 2 pi. Certainly we let n equal to 0, we have this point. This is when n equal to 0. And if we have n equal to 0, we have 13 pi over 2, 13 pi over 12, which is for n equal to 0. Now if we change the values, if n equal to 1, we have 13 over 12 for example, and then we plus 2 into it. Which is a lot more than 2 pi. So if it is between 0 and 2 pi, we only have one solution here and one solution over there. So there are two solutions here. So first, what we did is try to get the trig function by itself. To get the trig function by itself, and then depends on sine, cosine, or tangent, we can use the formulas. And for sine, this is supplement sine supplementary. So either that sine inverse or subtract from pi. And then this time solution from 0 and 2 pi, we have one solution on each side. And why we only have one value for each side? Because the period of sine is 2 pi. If we have 2 pi and the period is 2 pi, so if we have a solution here, adding 2 pi from it, it will be outside of this interval. Right, we'll get back to this when we have multiple angles later. Right, go to second example. Find all solution in degrees. In 0 to 360 degree, 0 to 360 for 2 cosine of x minus square root of 2 equal to 0. So will be similar to what we did here. First, we isolate the trig function by itself, and then we'll check the inverse. So we have cosine first, add the square root of 2 on the other side. So we have 2 cosine x equal to square root of 2. And then we divide by 2. So we have cosine of x equals square root of 2 over 2. So get the trig function by itself. We done that. Now for cosine, what will be the solution for cosine? So now we have the trig function by itself. Get rid of that. We just have x. And the first one is cosine inverse of that. And then plus n times 2 pi. And then for cosine, this is going to be opposite of cosine inverse. By the way, this time we use degrees. So n times 360 degree instead. Sorry. It be 1 degrees. Right. And is the calculator in degree mode? Yes. Now, even though if the answer is still in radian, I prefer to keep the calculator in degree mode when I do the trig inverse, because when we have the inverse function in degree mode, it is a lot better. The answer, that is. So we get that solution. Of course, we can also look at the unit circle. So anyway, x equal to 45 degrees plus n times 360. Over here, x equal to negative 45 degrees plus n times 360 degree. Right. Now notice that solution have to be between 0 and 360 degrees. So in 0 and 360 degrees. Now this one is simple. We just say 45 degrees. N equal to 0. That is when n equal to 0. That easy. We have one solution. If we choose n equal to 1, 360 plus 45 will not be in between 0 and 360. So we only have one solution here. If we subtract 360, it's not going to be between here either. So only one value for n. Now, but this one, if we choose negative 45 degrees, negative 45 degrees is not in here, right? So in that case, we have to choose some different values for n. So if we choose n equal to 1, x equal to negative 45 plus 360, this is 315 degrees. And 315 degrees is between 0 and 360, so that one's good. So we have the solution 45 degrees and 315 degrees. By the way, of course you can also say negative 45 degrees, but because this problem we want from 0 and 360, so we need to have an answer that is between 0 and 360 degrees. If it is not enough, if it is negative, we're just going to add 360 to it, or we subtract 360 from it until the answer between 0 and 360 degrees. So we have that. Right? And once again, what we did is isolate the trig function, and then for cosine is opposite. So sine is supplement with an S. Cosine is opposite, and tangent, there's no thing for tangent. But the period is going to be pi, right? Next, find all solutions of cotangent negative square root of 3. Right. So remember, we have equation sine equal to something, cosine equal to something, and tangent equal to something. That's good. What happened when we have cotangent? Or more general, what happened if we have secant, cosecant? Now this time we have cotangent. Remember, the calculator, on the calculator we only have, what was that? Sine inverse, cosine inverse, and tangent inverse. We don't have cotangent inverse in the calculator. So the way to deal with that is, first, cotangent equal to cotangent is 1 over tangent. Cotangent and tangent are reciprocal. Since we're going to cross multiply or flip or whatever, this I will write as negative square of 3 over 1. And then we're going to flip both sides. Tangent of x over 1 is 1 over negative square root of 3, or just negative 1 over square root of 3. Right. We have to do this when we have sine, when we have secant 1 over sine, or cosecant. Right. Secant is 1 over cosine, and cosecant is 1 over sine. Cotangent 1 over tangent. So we have to flip, use the reciprocal function, so that we're going to have sine, cosine, or tangent equal to something. Right. For tangent, remember there's only one solution, which is x equal to tangent inverse of that. But to compensate for only have one solution, we're going to use n pi instead of 2n pi for sine, cosine. For sine, cosine, there are two. For tangent, we only have one solution. And to compensate that, instead of 2 and 2 pi, we're just going to be a pi. Right? Now, what is the tangent inverse of negative 1 over square root of 3? So negative 30 degrees, which is negative pi over 6 plus n pi. And that's it. Right. That answer certainly works. But if you don't want that, let's say you don't want the answer that is negative, you can always add n equal to 1. We have x equal to negative pi over 6 plus, so I cannot write in pencil, okay, nobody can see it. If we have n equal to 1, x equal to negative pi over 6 plus a pi, negative 1, 6 plus 1 is 5 pi over 6. So instead of the answer in this form, you can also write the answer in this form as well. Right. So we have sine, cosine, and tangent. There are 3 different types of solution: sine inverse, cosine inverse, and tangent inverse. We always have that. The sine we also have the supplement. The cosine we also have the opposite. Tangent we don't have anything for that. But it's going to be n pi is that. Right. Let's take 5-minute break. We continue at 2:03. Right, we continue. So what we have instead this time is we have a quadratic function, meaning that we have more than just a values, we have a square of that. So in that case, not that bad if we just make a substitution by this. So if we let u equal to sine of theta, in that case we will have 2u squared minus 5u plus 2 equal to 0. And then this is just a quadratic equation. So the formula is quadratic formula negative b plus or minus square root b squared minus 4 ac over 2a. Right, negative, that's a 5 plus or minus 5 squared 25 minus 16, that is 9. So I have 5 plus or minus 3 divided by 4. So I have 5 plus 3 divided by 4, that is 2. And 5 minus 3 divided by 4, that is 1/2. So we have u equal to 2, and then u equal to 1/2. Now u equal to 2, now we substitute back in u is equal to sine theta equal to 2. Now the equation for sine, pretty simple. Theta equal to sine inverse n times 2 pi, or for sine it is the supplement. And what is in degree? Sine inverse of 2 is undefined. So in this case we have no solution because that one is undefined. So it's undefined, so we have no solution for that. But only one of it when u go to 2. When u go to 1/2, meaning that sine is equal to 1/2. And to get back to the angle, we have two solutions. The first one is sine inverse of 1/2 plus n times 2 pi the other one pi minus sine inverse of 1/2 plus n times 2 pi. Sine inverse of 1/2 is 30 degrees. Which is pi over 6. N times 2 pi or we can have pi minus pi over 6 plus n times 2 pi. And the answer must be between 0 and 2 pi. So we're going to choose pi over 6. And then here we have pi minus pi over 6. It's 5 pi over 6. So 5 pi over 6. And if we let n be 1 or 2 or something, it will not be in 0 and 2 pi anymore. So in this case we have two solutions. So there is nothing new here. For quadratic, just make that u and we'll do the substitution. Solve for u first and then solve for the trig function for each case. Right. Next. Find all the solutions for we have 2 cosine minus 3 cosine plus 1 equal to 0. Right. Same thing. We'll make the substitution u equal to cosine of x. And then we have the equation 2u squared minus 3u plus 1 equal to 0. Right. And now we just use quadratic formula again. Of course we can factor also, but sometimes this might end up with irrational solution. So it's better to just use quadratic formula. So negative 3 plus or minus negative 3 squared minus 4 AC over 2A. Right, negative 3, so that's 3, and 3 squared is 9 minus 8, 9 minus 8 is 1. So we have 3 plus or minus 1 over 4. 3 plus 1 over 4 is 1. And 3 minus 1 over 4, 1/2. So pretty much we have two solutions here. One of which is equal to 1 and one of which is 1/2. So first, for u equal to 1, we have cosine of u equal to 1. For cosine or sine doesn't matter. First thing is always the inverse. N times 2 pi. Or it's going to be, for cosine, it is opposite. Right. cosine inverse of 1 is 0. And then what is negative? Notice that positive 0 or negative 0, those are the same thing, right? So this we combine together. We just have u equal to, whether we have 0 or negative 0, we just 0, or just n times 2 pi. Now solution in here does not say between 0 2 pi or not. So the solution we just say n times 2 pi. Right, so one solution. Or u equal to 1/2. Cosine is equal to 1/2. We take cosine inverse. Or opposite. Cosine inverse of 1/2. (60°) or pi over 3. Or negative pi over 3 plus n times 2 pi. So we have 1, 2, and 3 solution. 3 set of solutions. Because this one we don't have any restriction between 0 2 pi, 0 and 2 pi. Yeah. So when we have quadratic equation, make a substitution, solve for that variable first, and then substitute back. We might have 2 of them that we need to solve for. Right. Next, sometimes we have to square both sides to solve for trigonometric equation. So sometimes we have the equation that have both sine and cosine. What we do here is we have to square both sides. And then you say, why do we have to square both sides? Well, because when we have cosine square plus sine square, that is 1. So first, square both sides. And square 3 square is 3. Cosine square is cosine square. And the square here a square is multiplied by itself, so I will multiply it out. Sine x times sine x, sine square, and then sine x, and then sine x. 1 1 is 1. And sine x make it 2. And then 3 cosine square. Note that we always have Pythagorean identity, cosine square plus sine square is 1. So if we want cosine square equal 1 minus sine square. And substitute into this cosine. That is the reason we square both sides, so we can have this identity to use. I multiply now 3 minus 3 sine square what I can do is I can plus 3 on both sides. I mean minus 3 on both sides to move everything to this side, and then plus 3 sine square so this side is going to be 0, and we have 4 sine square plus 2 sine x minus 2. Right. Just one thing to note that when we square both sides, we need to check the answer, because if we have negative 1, it's to 1. However, because sometimes when we square it, the negative or positive turn into the same thing, and we need to make sure that we don't have those cases. Bottom line is we have that. So same thing can be done. Let u equal to sine x. So this becomes 4u square plus 2u minus 2 equal to 0. And then we just solve for it. Quadratic formula. Negative 2 plus or minus 2 square minus 4 a c times 4. Right, negative 2 plus or minus 2 square is 4 minus 4 times 4 16 minus 2 32. 16 times 2 32 plus 4 36. 2 times 4 is 8. So we have negative 2 plus or minus 6 over 8. So we have 4 negative 2 plus 6 over 8 is 1/2. 4 over 8 is 1/2. or negative 2 minus 6 over 8 is minus 1. So we have u equal to that, and then u equal to negative 1. So we need to solve for both of them. U equal to 1/2, and u is equal to sine. And so we have the inverse. And then we have the supplement. Each sine inverse of 1/2 is 30 degrees, or pi over 6. And pi minus that is 5 pi over 6. Right. Next, we have u equal to negative 1, sine x equal to negative 1. Right. Either equal to inverse. Or the supplement. Sine inverse of negative 1 is negative 90 degrees, negative pi over 2 plus n times 2 pi. And then we have pi minus that. And pi minus minus will be 3 pi over 2. Alright. However, notice that though is 2. If you add 2 pi into this, you have that one. Notice if we add 2 pi to it, to have this one, because what we have here is negative pi over 2 is here, and 3 pi over 2 is also here. So those two solutions are the same. So in that case, we just need one. This one has no restriction, so we just say negative pi over 2 plus n times 2 pi. Right, so we have 3 solutions, but unfortunately, we're not done. This is a very long problem. Because earlier we square both sides, and every time we do that, we have to check the answer. So we need to check. Right. Let's see. What is x equal to pi over 6? Is that a solution? So we just check real quick. Cosine pi over 6. Is that equal sine of pi over 6? Plus 1. Right, square root of 3. Cosine pi over 6 is square root of 3 over 2. And sine of pi over 6 is 1/2 plus 1. So multiply square of 3, square root of 3. Yes, so that's good. Next, We check for x equal to 5 pi over 6 square root of 3 times cosine of 5 pi over 6 equal to sine of 5 pi over 6 plus 1. Right, cosine 5 pi over 6 will be second quadrant, negative. And sine 5 pi over 6 is 1/2. So this is negative 3/2, and this is 3/2. So when x equal to 5 pi over 6, one positive, one negative. When we square both sides, they're equal, but we do not have square both sides. So that is not a solution. So whatever solution here is not good. And finally, we check for negative pi over 2. Right, cosine of negative pi over 2. That is like cosine of negative 90 degrees. Is 0. And sine of that sine of negative 90 degrees sine of negative 90 degrees, is negative 1. Negative 1 plus 1 equal to 0. So that check. So when we check the answer, we will have two solutions, that and that. So when we square both sides, have to check the answer. And this is extremely long problem. There. Right. And so that's what we have. So when we have cosine and sine, we need to square both sides. And when we square both sides, we have to check the answer. And when we square both sides, use Pythagorean identity, so that we turn the equation into only one trig function, either sine or cosine. And then do the substitution, solve for it. There will be two cases. Solve for it again. At the end, we still need to check the answer. Right, quite a lot of work. Right, with that we go to section 6.3. We'll continue on the trigonometric equations. Now this is a little bit different. Let me zoom back in first. equation involving multiple angle. Find all the solution. In 0 and 2 pi for cosine of 3x equal to 1/2. Right, so what difference here is the 3 there. Right, so that's why we said we have involve multiple of an angle. Right, the good thing here is we're not going to use the multiple angles identities. We still just consider this. For sine, it's sine inverse and supplementary. For cosine, cosine inverse and opposite. For tangent, it just tangent inverse and nothing else. But for tangent, the period is a pi instead of 2 pi. Right, so similar to what we did before, we just say cosine. If cosine of 3x equal to 1/2, then we will say 3x inside the cosine is equal to cosine inverse of 1/2 plus n times 2 pi. And then for cosine, it is opposite. So we just find cosine inverse of 1/2. (60 degrees). 60 degrees pi over 3. Or we might have negative of that. Right, now we get back to x. So for x, we just divide by 3. Instead of divide by 3, we multiply by 1/3. So 1/3 times 1/3 is pi over 9. And then 1/3 times that is n times 2 pi over 3. And then same thing here, we should have negative pi over 9 plus n times 2 pi. Right, so up to this point, there's nothing new compared to what we have earlier. Cosine is still cosine inverse and the opposite. We just have to divide by 3 to solve for x, so it's nothing new. Right, what next is the new part. What we have, the solution is from 0 to 2 pi, right? I see that much. Now, but in our problem, when we have cosine of 3x, just like when we graph this function cosine of 3x, the period for this function is 2 pi divided by 3. And 2 pi divided by 3. Now, meaning that the solution will be for every 2 pi over 3. So the first one we have is pi over 9. The next one is we're going to add 2 pi over 3 to it. So we might have another one here. And then add 2 pi over 3, we might have another one here. And then add 2 pi over 3, we might have another point there. So how many of this do we have? Well, let's just try. When n equal to 0, we just have that. So x equal to pi over 9, which is good between 0 and 2 pi. When n equal to 1, x equal to what is pi over 9? I'm just going to write that out. N is equal to 1. So 1 over 9 plus 2 over 3. And that is 7 over 9. So that's good. It is still between 0 and 2 pi. We just have 0.77 clearly between less than 2. Right. Now n equal to 2. Two times 2 pi over 3. What is 1 over 9 plus 2 times 2 over 3. And that's still between 0 and 2, right? 0 and 2 pi, that is 13 over 9. Stick a pi to it. That one's good as well. Now n equal to 3. Now this is more than 2. So solution here doesn't work anymore because that is more than 2 pi. So we have 1, 2, and 3 solution here. Now do the same thing and choose some values here. Obviously, if we choose n equal to 0, it doesn't work because it's negative, which is less than 0. So I have to choose 1. And I forgot to divide by 3 here. Sorry. Right. Negative 1 over 9 plus 2 pi over 3. Sorry, there's no pi here, right? We always leave the pi out and at the end stick it back. Right, much better. 5 over 9. And that is between 0 and 2 pi. Right, next. Choose n equal to 2. Negative 1 over 9 plus 2 times 2 over 3. And that's still between 0 and 2 pi, which is good. 11 over 9. Stick a pi to it, and that works. Now n equal to 3. Negative 1, don't need to do that. Just go back there, highlight, hit enter, that copy and paste, go back and change to 3. Alright, that's still between 0 and 2 pi. But the fraction is 17 over 9. Stick a pi to it, and that's still between 0 and 2 pi. Now if we make n equal to 4, as is 2.55 something. It's way out of the 2 pi. It doesn't work anymore. So we have 1 solution, 2 solution, and 3 solution, and then 3 more. So we have 6 in total. So we have 6 solution. Right. Now notice. Now we go back to what we have earlier. From here 0 to 2 pi, the length of that interval is 2 pi. Now if we take the length divided by the period of the problem, divide fraction is multiply reciprocal, cancel out the 2 pi, we have 3. So 3 here means 3 values for n. Go back to our problem. Because the length, the period of the problem is 2 pi over 3, and you can fit 3 of them in the 2 pi. That's why we have 3 values for n. Yeah. So we take the length of the problem divided by the period. So in that case we would know that how many values of n that we need for the problem. Next, find own solution. In 0 and 2 pi for sine of 2x equal to -1/2. Right, there's nothing new here. For the sine, it's going to be the sine inverse and the supplement. So that's where we start. So we start with 2x equal to sine inverse. Because here we just have the sine, so we're just going to use that. Plus n times 2 pi. And then for sine, there will also be the supplement. To the sine inverse. Right. Sine inverse of -1/2. -30 degrees, -pi/6. And the supplement to that. Right, pi minus pi/6. And then plus n times 2 pi. So cosine is opposite, sine is supplement. Right. Now we solve for x, so we divide by 2 or multiply by 1/2. That cancel out, give us x. And 1/6 times 1/2 is 1/12. 2 and 2 cancel out. And over here, same thing. Right, except here we have 1 minus -1/6. And that is 7 pi/6, and then divide by 2. Right, and then 2 and 2 cancel out. So that is the general solution. And also in here we have 0 to 2 pi. So how many values of n do we need here? So for first, that the length of the interval is 2 pi. So the total length is 2 pi. How many of this we can put in? So sine 2x, the period is 2 pi divided by coefficient of x 2, which is pi. So when we do the length divided by period, two pi divided by pi is going to be 2. So we're going to have two values for n. Two values for n. So let's use two values for n. For both of them, that works. Now, if we choose n equal to 0, obviously negative doesn't work, right? It has to be between 0 and 2 pi. So the first one we want to start here is let n be 1. And we have negative 1 over 12. Just going to write down. Plus 1 pi. (11 over 12). Right, we know there are two values of n that will work, so there should be one more. That's still between 0 and 2 pi. Between 0 and 2, that is. But I need a fraction. Right, so there are two values for n. So we have two values for n. That works. Those two. Same thing here. I would use two values for n. The first thing I say, when n equal to 0, that certainly works, right? N equal to 0, x equal to 7 pi over 12. That's good. When n equal to 1, what is 7 over 12 plus 1? I change fraction. 19 over 12. And before we convert to fraction, we have 1.588. That's certainly between 0 and 2. 0 and 2 pi. So it's good. And here it says that we have two values for n and we have two values for n. So that certainly works. So that's when we have multiple angle. That's what we need to do. Certainly we do that. For feeling I write a little bit fast today. Right, as always, for sine, it's going to be inverse and then the supplement inverse and the sine is the supplement. And the period for also and the 2 pi. Right. Now this time we solve for x. So I will multiply by 2. But first, sine inverse of that. Negative 60 degrees, which is negative pi over 3. And we have pi minus that. Right, to get back to x, multiply by 2, and so we have x equal to negative 2 pi over 3 plus n times 2 pi, so n times 4 pi. And then here we multiply by 2 as well. And that pi minus pi over 3 and that is 4 over 3 and then times 2. So that is 4 pi over 3 and then times 2 should be 8 pi over 3 plus n times 2 pi times 2, so n times 4 pi. Right, the question is how many n do we have here? So this is a bit tricky. First, the length here is 2 pi. The period it's going to be 2 pi divided by the coefficient of x, which is 1/2. Divide fraction, multiply reciprocal, 4 pi. Right, so that's 2 pi divided by 4 pi. So we have 1/2, and we have 1/2 values for n. What does that mean? That means that n can be equal to 1 and can be equal to 0, but we have to be very careful with it. First of all, when n equal to 0, it doesn't work. So that doesn't work. When n equal to 1, what is negative 2 over 3 plus 4? This is way out of 2 pi also. (10 pi over 3), which doesn't work either. So the idea here is we have 0 to 2 pi, and our solution is 4 pi apart. 4 pi apart. So if we start here, outside with not a solution, and we choose to go 4 pi apart. If we go 4 pi out, we have the point here, and also not inside it. So if we have a very small period, we can fit a bunch of them here. If the period is way too long, it might not fit in at all. So in this case, there's no solution on here that will work. Next, when n equal to 0, we have x equal to a pi over 3, a over 3 is more than 2, so it's not enough. So if we just keep adding it, it doesn't help, so we have to go back. A over 3 minus 4 so that is negative 4 pi over 3. So that means we have no solution either. There is a solution, but not between 0 and 2 pi. If we want to check, we have sine of in radian. X over 2 and then we move that the other side, square root of 3 over 2, and let's graph. Forgot divide by 2, sorry. Right. So notice that I will zoom in, you will see. What I zoom in is between 0 and 2. Keep doing that. Oh man, I forgot. Let's do that again. I'm going to zoom about this windows. Zoom box. I am going to zoom over this windows. Right. So between 0 and 2 pi about 6.28. So 1, 2, 3, 4, 5, 6, 6.28. So there's no solution between 0 and 2 pi. There is the solution outside of it, but not inside. So in that case, we have no solution. That is between 0 and 2 pi here. I'm sorry. I know I will run out of time, but I just want to do one more before we go. Find all solution between 0 and 2 pi, because we haven't done anything that have the tangent in it. So let's say tangent of 2x equal to square root of 3, right? Do that simple. Right, for tangent, unlike sine, cosine, for tangent, it's just the tangent inverse, no supplement, no opposite. The only thing different is instead of n times 2 pi, it's just n times pi. So that is when we have the tangent, right? Tangent inverse of square root of 3. Have to go back to degrees. tangent inverse square root of 3. 60 degree pi over 3. So to solve for x multiplied by 1/2. 1/2 times 2 give us x, and pi over 3 times 1/2, pi over 6, and n pi times 1/2, n times pi over 2. Right, how many values of n do we need here? So first, the length from 0 to 2 pi is 2 pi. Next, the period for tangent to x. For tangent, typically is a pi divided by the coefficient of x. So it's pi over 2. And then if you take 2 pi over pi over 2, multiply reciprocal, pi and pi cancel out, we have 4. That means we're going to need 4 values for n. So let's choose some values for n. Just like this. If we start with 0, if it doesn't work, add something to it. If it is too much, subtract. And so that's the way it goes. So I choose n equal to 0. We have pi over 6, which is between 0 and 2 pi. That's good. N equal to 1. We have x equal to pi over 6 plus pi over 2. When n equal to 1, that's just pi over 2. 1/6 plus 1/2. And that is between 0 and 2 pi, which is 2 pi over 3. Which is good. N equal to 2, pi over 6 plus 2 times pi over 2. 1 over 6 plus 2 times 1 over 2. It looks silly typing like that, but we'll see. So that's still between 0 and 2 pi, between 0 and 2, which is good. 7 over 6, stick a pi to it, and that is good. And then n equal to 3. Even though this looks silly, but we just go up there, copy and paste. It looks silly because 2 and 2 cancel out, but since we have that, let's change to 3. This one still is between 0 and 2. Which is 5 over 3. It also works. And we have 4 values for n, and we have 4 values for n, so we have 4 solutions here. Of course, they say, can it be more? Oh, if we put 4 here, this is more than 2, so it's not in 0 and 2 pi anymore. So take the length, divide by the period, we have how many values of n that we can use. In this case, there are 4 of them. So then, once we find 4 of them, that's all. Right. So I just want to put that example here. And sometime when we have this, we will turn this into a sum to a product. When we use this identity, we turn a sum into a product, and then we go from there by the product. We don't have time, so but I think that's I want to cover this much for this section. So before I end the stream, do you have any question? one important thing here is after this section, I already post the note for day 13 and day 14 for chapter 7 and chapter 9. We will not have enough time to cover everything, so that's why I have to record it, those videos offline. You still need to watch them in order to do the homework and the test review and of course the test. Right. If you have no question, then I'm going to end the stream here, and thanks for being here. Have a nice day.